fine. Today I'm going to talk about communication protocols in computer networks. Basically, when we talk about communication protocols, they are protocols that aid in data transmission or data transformation from one network segment to another. And these protocols play a very important role in computer networks. Now, these protocols aid in data packet movement. Protocols are basically algorithms that perform certain functions to allow a specific function to perform. But one of the communication protocols I wanted to talk about is the TCP/IP. This protocol is a whole protocol that plays very, very serious role in networks. When we talk about TCP itself, it's a protocol that aids in transmission of data. And then the IP is a protocol that displays IP addresses to clients on the specific networks. So what is TCP/IP? It basically stands for Transmission Control Protocol / Internet Protocol. Okay, so the TCP/IP is a set of standardized rules that allows computers to communicate on the network, such as the internet. So it's a whole structured procedure format that allows computer to communicate. So any computers on the network can communicate through the TCP. And the TCP aids the communication through an IP. When an IP is signed to the client, the TCP will deploy that particular data to a client through that IP. That is why they move together. Now, the TCP itself is a suite of communication protocols used to interconnect network devices. So realize that it's a suite of, when we say something, it's made up of a pack of communication protocols. Now, it's also used as a communication protocol in a private computer networks, either an intranet or an extranet. So somebody will ask, how do this TCP and IP differ, the two of them? How do they differ? Now, the TCP and IP are two separate computer network protocols, because this one is Internet Protocol and the other one is Transmission Control Protocols. So the TCP is basically responsible for data delivery once that IP address has been found. As I said earlier on, data can be delivered to a client if the protocol, the TCP protocol, is able to identify that particular client through the IP address. So it's responsible for data delivery. Once the IP, so if the IP address is not found, the data will be hanging. Okay, so the IP address plays a very important role for TCP protocol to transmit data or to deliver data to a client, because the IP identifies each client uniquely on a network. Now, the IP is also a part that obtains the address to which data is sent. Okay, so the TCP is data delivery if only IP address is found, and the IP address is also the address in which the data needs to be sent. So think of this way. So let's look at this experimental scenario. The IP address is like the phone number assigned to your smartphone. So if you have a phone number 020 30 69 411, it is your IP address. It identifies you. You use that phone number. Nobody can use that number. So that is the IP. Then the TCP is all the technology that makes the phone ring. So you can see how interesting it looks like. So before you receive a call, the process that goes on for the phone to ring, for you to pick that call, is the Transmission Control Protocol. And that enables you to talk to someone on another phone. So the TCP is there to make technology work when there's calls. So before you pick the call, it's done by the TCP. If you're talking to a friend on another line, on another phone, it's also controlled by the TCP. But the IP address is your phone number. So they are different from one another, but they are all meaningless without each other. So they can work without each other, but they are different protocol standards. Now, what does TCP do exactly, and how does it work? That is the question I want us to discuss. What does TCP do at the end? How does it work? So the TCP was developed by a US Department of Defense to specify how computers transfer data from one device to another. Fine. So the TCP puts a lot of emphasis on accuracy, and it has several steps to ensure that the data is correctly transmitted between two computers So there is accurate standard performance when the TCP is doing its work. So if the system were to send a whole message in one piece, or if it were to encounter a problem, the whole message will have to be resent. So let's look at it. Instead, the TCP breaks its message into packets, and those packets are then reassembled on another end. As I said, how TCP works is very interesting. First of all, it will break the data packet, the data that is sent by the client, into packets. And after that, the packet can be routed to different destination points on the platform. Now, it also divides the different communication tags into layers. So the TCP itself is made up of 4 layers. Initially, it was 4, but now it has been upgraded to 5 layers. Each layer has a different functions like the OSI model. So each layer contains different performance, but you can find the layers in TCP also in the OSI model, because the transport layer in the TCP layer is also in the OSI model. Now, the purpose of this layer is to keep things standard without numerous hardware or software vendors having to manage communication on their own. So the TCP also has 4 or 5 layers as compared to the OSI model. But the layers in the TCP can also be found in the OSI model. So these 4 layers contains the application layer, the transport layer, the internet layer, and then the data link layer. Since we've done the OSI model, I don't need to go into details about these layers, because the same functions that they perform under the TCP IP. Now, are my data packets private? The answer is no. When the packets are being transmitted between computers, they are vulnerable to being sent by others. That's one reason why you are advised to avoid public Wi-Fi network when sending data that must stay private, and to use encryption. So when you are sending data, during the process of movement of data from one cloud to another, it becomes vulnerable. That is why we are not advised to use Wi-Fi networks. Or you need to encrypt the data before you send the data. Okay. Then does TCP IP work with all types of IP addresses? Whether it is class A or class B or class C, does it work with all types? There are several kinds of IP addresses, but whatever type of IP addresses we employ, it uses TCP IP. So it doesn't mind the class of IP. The class of IP addresses that you are using, the TCP IP will deploy, it works effectively. The difference between types of IP addressing are transparent to you as a casual user, and the fact that you don't need to know much about it is among TCP IP strengths. Okay, so it's like these matters are managed by whoever set up your computer operation system or mobile devices. So for clarity's sake, let's look at these 2 factors. There's static IP addressing that stays the same all the time, and then dynamic IP addressing that changes at any time t when you put off your machine, or when anything that you do, it changes the IP address. So these are the 2 types of applying IP addresses to that. I think we've done this thing earlier on in class. So what are the uses of TCP IP? What is it used for? Okay, so the TCP IP can be used to provide remote login over the network for interactive file transfer or deliver email. So most broadly, it is used to represent how information changes from as it travels over a network from one concentrated physical layer to the abstract application. So all what I'm saying is that TCP IP function by data delivery. That is the key. Data delivery. That's the main thing. So let's look at some of the pros and cons. Because definitely, since there is a protocol, there's limitations. So one of the main advantages of using TCP, it supports many routing protocols. And you know this routing protocol, like the routing information protocol, then the broader gateway protocol. So it also supports this protocol. It doesn't care. So the protocols in the router, the TCP IP, support that, so that you can route the data packet from different router to another router. It helps to establish a connection between different types of computers that will work independently. Okay, there is uses client-server architecture that is highly scalable. So when it's a client-server architecture, and the platform architecture is scalable and flexible. TCP/IP does well there. But let's look at some of the disadvantages. It's complicated to set up and manage. Yes, the configuration, you need a technical know-how person to do the configuration for you. Now the transport layer that is found on the TCP/IP and also that is found on the TCP and then also the OSI model does not guarantee delivery of packets. There can be some loss of data packets. It's not easy to replace protocol in TCP/IP. It's very difficult because it's standard. So these are some of the disadvantages of TCP/IP. Now let's look at the two. Let's compare the TCP/IP model and then the OSI model. That is an interesting area. Now the TCP/IP and OSI model are the most widely used communication networking protocols, and they are standard protocols. They follow standard procedures. Now the main difference is that the OSI model is a conceptual framework. Okay, it's like a conceptual framework. It doesn't take part, but it holds data transmission. Conceptual framework model that is not practically used for communication. It defines how application can communicate over a network. So the OSI model is just a framework that holds data transmission from one layer to another. Now the TCP/IP on the other hand is widely used to establish links and network interaction. Definitely yes, because it's for data delivery. That is another difference for the TCP. Now the TCP/IP protocol lay out standard on which the internet was created, while the OSI model provide guidelines on how communication has to be done. So the OSI model is just give you a framework that will provide a guideline that allows the TCP to perform its data. So therefore TCP/IP is a more, so the TCP use a layer, the OSI model use a layer. So the TCP layer is made up of 4, the OSI model layer is made up of 7. But you can find TCP/IP layers also on the OSI model layer. Although the TCP/IP consists of just 4 layers, while the OSI model consists of what? 7 layers, but they are intertwined. So the function performed on each model are also similar because it uses a network layer and transport layer to operate. So as I said, the TCP/IP has a network layer and the OSI model also has a layer. So you can see the similarities there. So the similarities between the two is they are both logical model. Well, it's true. Logical framework. They define network standard. That is also true. That's the similarities. They divide the network communication protocol in layers. That is another true. And then they provide framework for creating and implementing networking standard and devices because the framework is the backbone. Okay. Then they enable one manufacturer to make devices and network components that can coexist to each other. So because of the standard that OSI model and the TCP/IP, you can use HP switch, you can use Cisco switch on the same network because they are compatible. Let's look at the difference between the two. TCP/IP uses just one layer to define the functionality of the upper layers, while the OSI model uses what? 3 layers. That's the application layer, the presentation layer, and the standard layer. The TCP/IP header size is 20 bytes, while the OSI header is 5 bars. These are some of the differences. The TCP/IP follow a horizontal approach, while the OSI model follow a vertical approach. So these are some of the differences that we can mention. Thank you.